going to discuss on how to balance oxidation reduction reactions. Before we get started, let's have a quick recap of redox reactions actually are. And these are reactions where the transfer of electrons between the atoms during the course of the reaction itself. And this transfer of electrons, we notice causes a change in charges. We have elements that gain electrons, and as a result, our charge goes down. We have elements that lose electrons, and as a result, their charge goes up. And now, when we're going to balance this reaction, we need to worry about conserving. That's what balancing is all about. We have to conserve and balance for the number of atoms and its product. We cannot gain or lose atoms during the process of the chemical reaction. What's new in redox reactions is that we also need to balance for the number of electrons gained during the reduction process and the number of loss during the oxidation process. That number gained and number of loss must be the same from the very beginning to the end of reaction to ensure that no electrons have disappeared from our universe. Here are three types of redox reactions that will be responsible for balancing reactions. These are neutral conditions, the easiest among the three. Then we have acidic conditions. Acids are solutions that contain atoms with an H plus ion that defines them as acid. And lastly, basic conditions. Basic are solutions that contain reactions with OH minus ions, the hydroxide ions. With the help of the extras H plus ions and OH minus, we can use that to help in the balancing process, which will make sense later. Before we move on, you'll notice below we have something already familiar to you, and that is the pH scale level. That is a way of measuring the acidity of our solution. If you recall, pH below 7 are the acid ones, while the pH above 7 described as either alkaline or basic. And of course, at the pH of 7, they're neutral. Now, we are set to the rules for balancing our redox reactions. All we're going to be writing down in a moment is a set of steps to follow to balance all types of redox reactions. So this step will balance neutral, acidic, and basic. But keep in mind that depending on what type you're actually balancing, you may not necessarily need to do all the individual steps. Some steps are specific to acidic, some steps are specific to basic, and some steps apply in all three cases. So here are steps in balancing redox. You can pause the video or write these rules down yourself. In this video, we're going to focus on the half reaction method used to balance redox reaction, the neutral, acidic, and basic solution. So let's start with our first example in this chemical reaction, the neutral solution. Using the half reaction method in neutral solution, you need to make sure that not only the particles are balanced, the atoms and ions, but also the charge must be balanced on both sides. Here is the example. In redox reactions, it can become more complicated if molecules of solvent are involved in a chemical reaction as water molecules can be. If the reaction is carried out in aqueous solution, hydrogen atoms or oxygen atoms from water molecules can be incorporated into these substances, which will make it a little trickier to balance the corresponding equations. To balance the acidic reaction, we can use the half reaction method to balance the equations of redox reactions occurring in aqueous solution. In this method, a redox equation is separated into two half reactions, one involving oxidation and one involving reduction. Each half reaction is balanced for mass and charge, and then the two equations are recombined with appropriate coefficients so that the electrons cancel. To balance more complex redox equations, it is sometimes necessary to add hydrogen ions and water molecules, a reaction that occurs in acidic solution. In this video, we'll walk you through this process for the reaction between dichromate ion reacting with iron 2 plus to yield with chromium 3 plus and iron 3 plus.
If this is occurring under basic conditions, the algorithm will just be a little bit different, but it will start out by balancing as though we are under acidic conditions. When balancing equations for redox reactions occurring in basic solution, it is often necessary to add OH- or hydroxide ions, and also to add water molecules to fully balance the equation. In this example, we have solid silver reacting with zinc 2+ to become the silver oxide and solid zinc.
There you have it. It's time to wrap up redox reaction. Thanks for watching. Peace out.